Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, Official Guide to the Revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 231. Please turn to it, page number 231, and today is our lesson number 323. This problem that you see there on page number 231 is the exact same problem that appeared in the first edition of the revised GRE. We have already solved every single problem out of this book. If you're interested in watching the original solution, you will find the original solution on day number 110. Here's how the problem goes. We are told that A can do the job in 3 hours. We are told also that B can do the job, the same job that is, in 2 hours. And the question simply is, how long will it take them if they were to do the job together? Simple enough question. Now listen, there are several different ways we can go about it. One method, of course, is the one that you see in the book in front of you there on page number 231. There is nothing wrong with that method. That method that you see in the book is the most classical, most orthodox, most traditional, most academic, most nerdy, most geeky method that you can find. Of course, that's not the only method. So here's another method. Now, just to make it interesting, I've given you 5 answer choices. The 5 answer choices that do not appear in the book there, but on the exam, of course, you will be given, most likely, it will appear as a multiple choice question, and you'll be given 5 answer choices here. So here are the answer choices: 5, 6, 1, 1 and 1/5, 1.5, and 2.5. Here's what we ask ourselves. In a situation like this, in a work problem, what we ask ourselves is, what is the range of possibility here? What's the best case scenario? In other words, what's the least amount of time that can possibly take for them to do the job together? What's the worst case scenario? What's the most amount of time that they can take to do the job if they're working together? And that will be determined by asking ourselves these two questions, these two hypothetical questions. The questions are not hypothetical, but these two hypothetical situations. Ask yourself, if the slow guy all of a sudden, if the slow guy works as fast as the fast guy, if for some strange and inexplicable reason, the slow guy decided to put his derriere in the 5th gear, and he decided to work as fast as the fast guy, well, fast guy can do the job in 2 hours. The fast guy can do the job in 2 hours. Well, if you have 2 people and each of them is capable of doing the job in 2 hours, putting them together now should take only an hour to do the job. Because in 1 hour, one is going to do half the job, in 1 hour, other one is going to do the other half of the job, because individually they take 2 hours. So together they will take only 1 hour. Simple enough. So if the slow guy works as fast as the fast guy, the job should take 1 hour. But of course this is hypothetical. This will never happen because the slow guy is not working as fast as the fast guy. This is purely hypothetical, which means it will never, this is the best case scenario. In other words, the job can never take 1 hour or less. It can never take 1 hour or less. Now let's ask ourselves the other extreme scenario. What happens if the fast guy for some reason decided to take as slow as the slow guy? If the fast guy works as slow as the slow guy, the job should take how many hours? Well, the slow guy, we are told, takes 3 hours. If he takes 3 hours, and now if you have 2 people, each of them is taking 3 hours to do the job, if you were to put them together, the 2 identical people, each of them taking 3 hours to do the job, together they will take 1.5 hours. They will take half the amount of time, because they are 2 people working at the identical speed. 3 hours to do the job for one person, 3 hours to do the job for the second person. In other words, in 3 hours they can do 2 jobs, therefore one job will take 1.5 hours. There you go, this is our range. This is the best case scenario. It can never be 1 or less. This is the worst case scenario. In other words, this tells us, if you were to put these together, if you were to put these two situations together, this tells us that the correct answer, whatever it is, should fall between hour and a half and it should say hour and hour and a half. It should between hour and hour and a half. This tells us that the correct answer, whatever it is, should fall between 1 and 1.5 hours. Anything that falls outside this range is not correct. The job cannot take 5/6 of an hour. It can never take 1 hour, because that's the best case scenario. It will never happen. The slow guy is not working as fast as the fast guy, and fast guy is not working as slow as the slow guy. So the job should never take more than hour and a half. Do you see any answer choice that is more hour and a half or more? Well, there you go. D is gone and E is gone. There is your answer. Answer is 1 1/5. That's it. We are done. That's it. We are done. Let's do a second method, shall we? Let's do one more method. And you'll be surprised. I'm not suggesting at all that doing this method will always allow you to eliminate 4 of the 5 answer choices. But I guarantee you, you will be able to eliminate 2 answer choices, in many cases as many as 3 answer choices. At that point, you make a call. If you want to invest more time into it, go ahead and do it. But if the time is running out, or if it's giving you difficulty, you don't know what to do next, then once you narrow down your answer 50-50, there is no shame in flipping a coin. Pick one and move on. That's all. Don't waste too much time into it. If you're able to eliminate 2 or 3 answer choices, you're doing very well. You understand? You're doing very well in the sense that you're doing very well for a person who is either running out of time or does not know how to do the problem. In that scenario, that's the next best situation. Just eliminate, make intelligent guess, in other words. Let's do one more method. Second method. Second method is also very straightforward. In the second method, what we look for is the common multiplier. Least common multiplier here. We have 3 and a 2. The least common multiplier is 6. So this is what we ask ourselves. We ask ourselves, how much work can they do individually in 6 hours? Well, we know that A can do the job in 3 hours. If A can do the job in 3 hours, then A can do 2 jobs in 6 hours. Now where does 6 come from? Well, 6 is just 2 times 3. Is the least common multiplier. It's the smallest number that you can find, that is the multiple of both 3 and a 2. B can do, B takes 2 hours. B takes 2 hours to do the job. Therefore, in 6 hours, if it takes 2 hours for him to do the job, in 6 hours he can do 3 of these jobs. Together, they can do 5 jobs in 6 hours. Together, if they're working together, they can finish 5 jobs, because in 6 hours, one guy can do 2 jobs, in 6 hours the other guy can do 3 jobs. So if you're working together, if you put them next to each other and give them 6 hours to do the work, they can do 5 of these jobs. If they can do 5 jobs in 6 hours, therefore, if they can do 5 jobs in 6 hours, that implies that they can do 1 job in 6/5 of an hour. That's it, we're done. 5 jobs in 6 hours, so one job is going to take 50 amount of time. If 5 jobs are taking 6 hours, one job will take 50 amount of time, so it's just 6 divided by 5, that is 6/5. That's your answer, C. Now here's what I want you to do. I'm going to give you a problem that we're going to work on tomorrow. But I'm going to give you the problem right now. We're going to set it up right now, and I want you to try it on your own before you watch the next video. Alright? It'll be interesting. Use both the methods, don't just use one method, try it with both the methods that we just learned. In the first method, we look for the range, upper bound and lower bound. In the second method, we find the least common multiplier of all the numbers that are given to us, and we ask ourselves how many jobs each of these individuals can do in that amount of time. So here's the problem for tomorrow. I'll get out of this again one more time very quickly. Here's what happened. So this guy can do the job in 3 hours. B can do the job in 2 hours. The common multiplier, least common multiplier of 3 and 2 is 6. So we ask ourselves, how many jobs can A do in 6 hours? A can do 2 jobs in 6 hours. How many jobs can B do in 6 hours if it takes him 2 hours to do the job? Well, B can do 3 jobs in 6 hours, which means together they can do 5 jobs in 6 hours. Well, if they can do 5 jobs in 6 hours, one job will take 50 amount of time. Whatever that amount of time was, a fifth of that. 6/5, that's it. That is it. Here's the problem for tomorrow. A can do the job in 2 hours. B can do the job in 3 hours, and C can do the job in 5 hours. This one right here will go right here. A, B, and C. That's it, we're done. That's the question. The question is very straightforward. The question says, if A can do the job in 2 hours, B can do the same job in 3 hours, and C can do the same job in 5 hours. Now we have 3 people, A, B, and C. First guy takes 2 hours, the second guy takes 3 hours, third guy takes 5 hours. The question is, how long will it take them to do the job if all 3 of them are working together at their respective constant pace? And here are the answer choices. Two-thirds, 1 and 2/3, 2 and 2 1/2. You work on it yourself. Make sure you do it yourself before you watch the next video, tomorrow's video, day number 324, which is going to be, I can't talk without my pointer in my hand, which is going to be the very last one in our series, 505. We have done, well, no, I should say we will have done by tomorrow, by next video, we will have done 5 work problems. First one was on day number 260, if you want to watch it. The second work problem, we did it on day number 261. The third one was day number 262. And today we did the fourth one, which is day number 323. Tomorrow we'll do the very last one of the series on day number 324. Alright? Bye now.